Okay, I need a couple of... We're going to go over a couple of tidbits of information for problem solving today. One of them sort of almost got mentioned. What is a conversion factor? I've already asked you this definition before. What is a conversion factor? You don't look anything up. Anyone? Bueller? Wait, what? How many things are involved? Two. Two things that are equivalent to each other or equal to each other, we can make a conversion factor out of. Does anyone remember me mentioning this before? Okay. There's going to be, when we start doing this problem solving thing, that's going to come up fairly often. Okay, I'm sure you guys have all been given story problems in which you kind of looked at it and stared at it for a little while, having absolutely no idea where to start because there's like 8 different numbers in the thing, kind of like what you were talking about a little bit ago here, Haley. You didn't know where to start, so you just picked the first thing that came up, right? That happens, and so what I'm going to do today is show you a technique that will help you, I hope, determine where do I start. So let's walk through that process right now. Oh, I don't want that. Go away. All right. So can everyone see this question? I can make it a little bit bigger. Not by much, but I can make it a little bit bigger. That better? Okay, so here we go. So when we look at this question, not that you guys couldn't solve this on your own anyway, okay? But what I'm trying to do, if you remember, is give you guys ways to solve them effectively, meaning accurately, and efficiently, meaning quickly. The faster you guys get these things done, the better you're going to end up being because you're going to be able to spend time on things that maybe you do not understand as well. So the first, in my opinion, first thing you should do whenever you're given a question like this, the first thing you should do is identify any possible conversion factors, meaning two things that are related to each other. I'll give you guys a few seconds to kind of look this over. And if you think you have found a conversion factor, let me know. Try not all to speak at once because your voices cancel each other out, kind of like what's going on right now. You're still doing it. Hey, we've got one. Hannah, right?
Yeah. There's liters per hour.
Oh, time down. Don't do it. Be specific. 14.6 liters of hydrochloric acid per hour. Now, how did you know those two things were related to each other? The per. Thank you. And what does per mean mathematically? Divide. Good. That's a clue. That's something to look for. I'm going to underline that. I would recommend to you guys, whenever we go through things like this, that you also somehow indicate or identify that. I'm going to underline it. You had your hand up, Aaron. One of you, Aaron's. Yes. 518.6 hours. Okay. So there's another one. Oh, wait. There we go. Going to underline that one. Are there others? 1 month equals 30 days. You guys see what we're doing here? Does that make sense to everyone? Would you agree that those are equivalents, each set, right? Step 2, once you have identified all the conversion factors, like we have done, my suggestion is to find the quantity that we're trying to solve for. What are we trying to solve for? Yes. Gallons. We're looking for gallons. I am going to give that one a color, just so we can focus on it. Okay? And orange it's going to be. We're looking for how many gallons? Would you guys agree? What's left? What's that? That's what we start with. This is what I would do. I would write down 62 days. So what were the 3 steps? First, identify conversion factors. Second, determine what it is we're trying to solve for. Whatever is left over is what we start with. You can't screw it up. Keep that in mind. 62 days. So, now, how can I go from days to gallons? Someone tell me how I'm going to get there. What's that? Hours. And from hours I can go to... I think we may have skipped a step somewhere. Say this again. Yeah, we're going to have to go days to month. Would you guys agree now? And once we go from month, we can go from month to hours. And from hours, we can go to liters. And from liters, we know a way to get to gallons, yes? Boom, there we go. So there's our plan. And so now it's just a matter of just throwing it all together. So take my 62 days. We know there are 30 days in a month based on that last conversion. And we know that there's 500, the pump will work 518.6 hours per month. And we know that we can get 14.6 liters per hour. And of course, everyone has memorized the conversion between liters and gallons. And you'll notice my days cancel, my months cancel, my hours cancel, my liters cancel, and by golly, there we go. That makes it pretty easy, doesn't it? I'm sorry, what? Well, the days cancel, the months cancel, hours cancel, liters cancel. Where's everybody going?
We're getting our calculator.
I wondered what was going on. I thought everybody was like backing up and going away. It's like,
Like, we're done with this class.
1,000, 250, 25, 250, 375-ish, 400. I'm just. What is it? 4,000. I didn't move my decimal point over. 4. Yeah. Yes.
When you cancel out the days, what are like the liters? I'm really confused how you're canceling.
Okay. Numerator, denominator, gone. Numerator, denominator, gone.
Oh, I understand. If they're equal, like 1 month and 1 month is equal, so if you cancel it out, well, 14.
I'm not canceling out numbers. Did you see me put a line through any number? Okay. What was again? 4,000? 4,134 point blah, 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 blah. Okay, so anyway, where I'm going with this, how many significant figures are necessary in our answer? 2. So my answer would be 4,100 gallons. Pretty good? That's a pretty nice way to do things, isn't it? Okay? Obviously, as always, I would like to give one for you guys to try on your own. So...
Oh, I got it now. Okay. That's not the right answer.
Give this one a shot. You know, I get that not every one of you needs like instruction on how to do story problems like this, word problems like this. But over the years, I found out the majority of you do need at least a little bit of like a head start or whatever, a technique, and so this is providing that. Ah, you're discovering something. One of the Aarons, possibly Aaron squared, just figured something out.
I'm guessing it's you, Aaron Taylor.
Now, one of you is the square root.
Well, no, she's going to be there. I don't know where to even start.
Are there any conversion factors?
No.
Are there two things that are equivalent to each other?
What are you talking about? Oh my God. I don't know. No? Yeah. What is one barrel? Oh.
You should have seen the eye roll she just did.
Oh my gosh.
Alex, how are things going over there? Okay. I haven't heard much from you. That's why I was wondering.
I'm honestly just the most confused person on earth right now. But hold on, give me some more time.
Were you done like 5 minutes ago?
Do we start with...
You're not sure?
Do we start with...
Yes.
And I'm not done yet. Start with learning one gallon, or do we start with... I'm almost positive.
Here's the that you're done. Why are you frustrated with that? I know why.
I didn't use this number.
You didn't. I've got an answer for that a little bit later from now. Very good. You didn't like that, did you? I'll give you the analogy here in a little bit.
What does 85.6 liters have to do with anything? I'm just going to start with... Because a barrel equals that many gallons. Yeah, 10,000 gallons by that.
Okay, here we go.
Right? No.
Are there any conversion factors embedded in the question? Such as?
I read this wrong. Oh my God.
Okay, so a barrel of oil has a volume of 31.5 gallons. Are there any other conversion factors? 1 barrel equals 85.6 liters of gasoline. And we now are discovering that not only do all of our values need a unit, but often and almost always need a label. Label and unit aren't the same thing. In this case, it's 85.6, that's the value. Liters, that's the unit. Gasoline is the label. Because we can have liters of anything, couldn't we? Right, so we have to indicate which one we're talking about. And then, what is it we're trying to find? How many barrels? So, let me find my thingy here. There it is. How many barrels? So I'm going to highlight that one in orange to kind of help us focus on that. Which means, what are we left with? 10,000 gallons. So we come over here, write down our 10,000 gallons. And now I need to get from gallons of gasoline to barrels. How can I get there? I can go gallons to liters. We know how to do that. We did that one last problem. Now I can go from liters of gasoline to barrels of gasoline, because we know there is 1 barrel for every, what's the value, 85.6? My gallons of gas cancel, my liters cancel, and I'm left with barrels. And what am I trying to find? Barrels. Done. I'm waiting for someone else to ask. It'll happen. Look, Aaron's about ready to do it. Go ahead. Oh, okay. For what? No. You can have 6 of them tomorrow. No, we don't. Yeah. Over what? That's what I said. Does anyone have any questions on this one? There we go. Yes.
Do we not use the 31.5?
Did you use it? Let me ask you something. Is there a toolbox at your home? Is it filled with tools? Have you ever used any of those tools to fix something at home? Oh. Have people in your family used something out of the toolbox to fix something? Did they use every single tool that was available? No, that was just a tool that was available. You don't like that analogy, do you? What's that?
Could you have used like the oil thing? Could that?
But here's the thing about the oil thing. There's no other oil up there.
Well, 1 barrel oil produces.
Yeah.
You're just making it complicated. It doesn't have to be.
In life, you have choices. You have to figure out what you need and what you don't need. You don't need it all. Okay. Any other questions? All right. Well.
Whoa! That's so cool! It's infinite.
Okay. math lesson. Does anyone know of any other equations incredibly similar to this one that you're familiar with that you've used at some point in your life? Pardon?
No, I don't know.
I'll give you a hint.
Velocity and, gravity or something. I know what it is. Distance divided by
Speed equals distance over time. Velocity equals displacement over change in time. Whatever, okay? Where I'm going to go with this, I start off with two really, really easy equations. I want to show you guys something. Once again, is it possible that many of you don't need this information? Possible. Is it likely that a lot of you do? Absolutely, because I run into this problem every year. What I'm going to do is show you how to rearrange equations. Once again, what are the two words? Effectively, right? And efficiently, quickly. Okay? Now, I'm going to do it the way you were taught in math first. So what I'm trying to show you is I'm not violating any math rules, okay? But there's a faster way to do things. So, here we go. Let's imagine that we're going to solve this equation for volume. Here is the one thing that I find students doing. You guys know there's two rules that must occur, or two things that must occur whenever you're solving for a variable. The first one's duh. The variable has to be by itself. You guys get that, I hope. Okay? The second one is the one that causes problems, and that is that the variable also has to be in the numerator. You guys are really good at isolating a variable and having it by itself, but being in the numerator is where we sometimes mess up. What can be said of this variable right here that we're trying to solve for? Is it by itself on one side of the equation? No, we got this over there. Is it in the numerator? It is not. We got to take care of that too. Now, the way you guys were taught to do things mathematically correctly is, well, I need to get this in the numerator. So what I can do is multiply by the reciprocal. And whatever you do on one side of the equation, you do to the other side. So I'm going to multiply this by the reciprocal. They cancel out on this side, and there I have this. Remember, I'm still solving for this, though. Is it in the numerator? Absolutely. Is it by itself on that side of the equation? It is not. So what do I have to do? Well, multiply by the reciprocal. I'm multiplying by the reciprocal. And what do you do on the other side? Multiply by the reciprocal. Because your math teachers kind of lied to you. What you do is you multiply by the reciprocal. That way it's the same rule. You don't multiply or divide, you multiply by the reciprocal. So now watch what happens. The densities are gone. Would you guys agree? And what am I left with? Volume equals mass divided by density. There's how you do it mathematically. Now, let me show you how to do that the fast way. Okay? Here's the variable that I'm solving for. Once again, what must be true of that variable when we've got it isolated? By itself in the numerator. Where did the volume end up when we were all done over here? And when we were done, it was volume equals mass over density. Where did the volume end up? In the numerator. Put it there. Now, how did I get it there? It started off in the denominator and it ended up where? Boom. Put it there. Where did the density end up? In the denominator. It started off in the numerator, but it changed sides, right? Boom. Here's the rule. When you're moving variables, move them diagonally. If they start in the numerator and you move it to the denominator. If it starts in the denominator and you're moving it, move it to the numerator on the other side. You guys see how it works out? Now, did I end up with exactly the same equation? But did it quite a bit more quickly. Now, here's the thing. This is an equation that you guys are familiar with and comfortable with. You've used it before. I'd say probably the same thing here, right? I'm not as concerned with these little equations like this. It's the ones that we run into later in the course that do possibly concern me. So, in the 2 minutes that we have left, I'm not going to make you do that, but we will start there tomorrow. I'm going to give you like 6 equations, have you rearrange and solve for a different variable, see where we end up. Nice job today, everyone.
So we don't have homework for our quiz tomorrow?
Oh, wow.
I'm sorry.